maximize or minimize things, namely like maximizing profits, minimizing costs, which obviously would be helpful in a business sense. So, and then the idea, I think I mentioned this on Friday, with that idea that when you're making something, you don't just have unlimited resources, that there's constraints on your ability to spend time doing something, there's constraints on the amount of materials you have, and things like that. So you can't just make and then make money. So there's limits, and so that's what these inequalities do for us. They are fairly in-depth problems. There's a lot for us to do here. So of course, I need you guys to make sure you're speaking up if things aren't making sense. So, but the first thing we want to do is define our variables, and that's just like how we talked about it, a week ago when we were doing the systems of equations with the word problems. That we want to start off by making sure we understand what we're looking for, and naming that, and being really clear about what it is exactly we're looking for, and then you're going to write what's called an equation, which is called the objective function. So this deals with the main objective of the problem. It's going to be one of the things that's a little bit trickier about these problems is there's two questions, and that answering the first question is going to really help you find the answer to the second question. So usually the objective function is the one that talks about how do we maximize or minimize something. So here with this problem, it's going to be about getting this highest score. Okay, so that's going to deal with our objective function. Then we're going to write a system of inequalities. So what we were graphing on Friday, system of inequalities. But these inequalities are called our constraints. So what are the limiting factors to what's going on? And those should be our inequalities, that we don't have infinite amount of supplies or resources or time, stuff like that. So, once we have those inequalities written, we'll graph them. We're going to find the vertices of the shape that's formed. So just like we saw, on Friday, there's often a shape formed, and we're going to look for those vertices, which are the corners of that shape. And those vertices, those points, are going to get plugged into the objective function. So we use the constraints to graph. We then take the graph, find its corners, and plug those back into the objective function. And then we look for that least or greatest value, depending on what the objective is. So lots of steps here to go through. And so make sure you're speaking up if something's not making sense. So just always, the first thing I want to do is just read through the problem, just get a sense of it, see what's going on. So Algebra 2 quiz consists of computation problems and graphing problems. Computation problems are worth 6 points each. Graphing problems are worth 10 points each. You can answer a computation problem in 2 minutes and a graphing problem in 4 minutes. You have 40 minutes to take the quiz, and you may choose no more than 12 problems to answer. Assuming we answer all the problems correctly, how many of each type should we answer to get the highest score? So we need to start off by defining our variables. What is it that we have control over that we don't know? Okay. So looking usually towards the end of the question to see what it is they want us to figure out. So one thing they're asking for sure is how do we get the highest score? But really the first question is how many of each type of problem should we answer? So I told you guys last week that you can pick whatever you want, letter you want for your variables. Now I'd really tell you that you should pick X and Y because we are going to graph these, and you don't want to have like a C axis and a G axis. You want to just call it an X and a Y axis. So picking X and Y because it'll be easier to graph with X and Y. But you get to decide which one's X and which one's Y. Okay? The other thing you don't get to decide though is question, right? What don't we know about these computation problems and these graphing problems, right? We know how many points they're worth. We know how much time it takes us to do them. What we don't know, again, is that question of how many should we answer, right? So that needs to be part of your variable. So I like to use the phrase like number of. You could say amount, okay? You could say how many if you wanted, but number of. And then, again, I get to decide which one's X, which one's Y. my general habit is to pick the first one to be x and the second one to be y. Just kind of a habit. So number of computation problems to do, and then the number of graphing problems to do. Okay. So don't just write computation problems, don't just write graphing problems, make sure you're talking about the quantity, like how many should I do, right? Needs to be the question here. Next thing I want to do is write my objective function, okay? What's an equation that I can write that deals with the overall objective of getting this highest score? So I need to think about how we get points, right? If we want to get a score, we need to talk about points. And talks about that the computation problems are worth 6 points each. When we see a word like each that says I need to take 6 points times however many computation problems I'm going to do. Well, how many computation problems am I going to do? Right? Well, right now it's just x problems. We don't have a value for that. So 6x will be how many points I have for all my computation problems. And then the graphing problems are worth 10 each. So again, that word each means to multiply. Well, how many graphing problems am I going to do? Don't know yet. That's why it's called y. So 10y. So 10 times y. Well, if I take all the points from my computation problems and I take all the points from my graphing problems, I would add them, and then that would give me my total score. So we get to name this function. Okay? Usually if it was like a profit function, we would call it P. If it was a cost function, we would call it C. Here, this is talking about points, or it's talking about score, so I might be tempted to use the letter S or P. But I don't really have a strong feeling otherwise about what letter to use for the name of this function. Samantha, would you like to use S or P or something else? P? Okay. So Samantha like to use P for points. All right. So I take the points from my computation problems, I add it to the points from my graphing problems, that would give me my total points for my quiz. So there's our objective function. Once we have that written, we just kind of leave it alone for a little while. We don't need it for a minute. But there's the objective function. So we've done step 1 and step 2. We've defined the variables, and we've written our function that's going to be maximized or minimized. Anything so far you guys got questions about on either of those? So then we need to go look and say, well, what's limiting us? Why don't we just answer all the questions and get all the points, right? What's limiting us in this problem? Okay, so Aiden said we can only choose 12 problems to answer. So if we think about what X and Y stand for, X stands for a number of problems, and Y stands for a number of problems. So if we took a number of problems plus a number of problems, we should. Well, it's not an equals, though. So X and Y, when we add them, right, it can choose no more than 12. So we need to decide, right? What is it? Is it less than or equal to? Is it greater than or equal to? Is it just, greater than? Is it just less than? All right, you guys got to stop and think. What's the problem telling us? This one's being fairly straightforward. It uses a phrase like no more than, okay? Which does mean that these numbers over here do need to be, they do need to add up to be less than 12. So like what would be acceptable is another way to think about it. If I can answer no more than 12, what would be acceptable amounts of problems to answer? Like 12, 11, 10, 9, 7, right? All of these numbers are less than 12. So just helping you decide that this does have to be less than or equal to 12. Right? And probably the biggest / easiest mistake to make with these is to flip that around, because then your shading is going to be in the wrong direction, and that's just going to mess everything up. Okay? So being really careful about how you arrange that inequality symbol. Okay? Well, what else is constraining us in this problem? We only have 40 minutes to take the quiz. So Well, what else is it about time that they're telling us, right? It's that computation problems take us 2 minutes each. So every time I want to go and do a computation problem, I have to spend 2 minutes each time. So that's 2 times x. Every time I want to go and do a graphing problem, it's going to take me 4 minutes each. So that's 4 times y. Well, if I take the amount of time I do one thing plus the amount of time I do the other thing, I should get my total amount of time, which is, the 40 minutes we have. But then again, how do we arrange our inequality? Is it less than? Is it greater than? Is it less than or equal to? Is it greater than? Yeah. So Aiden's saying we don't have to take 40 minutes, but we have 40 minutes, maximum.
You can complete it at exactly 4 minutes.
And we could complete it in exactly 4 minutes, right? So we could say 40 minutes or less, right? This time over here has to be, it could be 35, it could be 39 and a half, but these have to add up to be less than or equal to 40. But nowhere in there did it say anything like that. It just said, hey, you've got 40 minutes. But you guys have to stop and think, well, what does that mean? Okay? So it's really, I think, as far as like mental energy goes here, like really making sure you're understanding why these are in the direction they are. Is going to be really important. Again, if you mess the shading up, your problem's just, there's nowhere to recover from that. So making sure really well that these are going the right way. Anything about the writing the inequalities you want to talk about before we move on to the next piece of that? I think you guys are not sure about with how we wrote those. Addison, you doing okay? Jubal, Sophia? Okay. So just like we talked about on Friday, they have to be in slope-intercept form before we can graph them. So I need to get y by itself. So on that first one there, I'm just going to kick that x over. So y is less than or equal to negative x plus 12. On the next one, I need to kick the x over. So 4y is less than or equal to negative 2x plus 40. But then I need to divide everything by 4. So y is less than. So negative 2 divided by 4 would be negative 1/2. So negative 1/2 x, and then 40 divided by 4 is 10. Say again, Brian? Yeah, divide everything by 4. Yeah, divide the whole inequality by 4. So there, we're ready to graph now. You have the two inequalities in slope-intercept form. There are also two kind of implied inequalities here that we can't answer negative problems. So x would have to be greater than or equal to 0. And same thing with y. So these are kind of just implied. And it's not that big of a deal if you don't address these. But yeah, we can't have negative problems answered. So again, not a super big deal if you don't put those down, but they are kind of there. So when I'm going to go and graph this, and I gave you guys blank coordinate planes on a purpose. Like, we do not want the axes in the middle, because that would give us all this space on the left and the bottom that's useless, because we're not going to have these negatives. So in real life problems, you tend to use that left axis and that right axis, and the bottom axis, not the middle axis. So that's what I'm going to use here. And now I need to think about my scale. Like, what am I going to count by? There are 20 boxes here. Okay? As I'm looking at the numbers that I need to have, I see a 12 for my y-intercept. I see a 10 for my y-intercept. There's no way for me to count by anything more than 1 to get to a 12. So I'm just going to go ahead and count by 1s on my axes. If you change the scale, you have to label it. If you're counting by anything besides 1, you have to label it. Even if you are counting by 1s, it's a good idea to do some labeling. I personally like to go and label every 5. I think that helps me count better. Helps me find, like if I needed to find 17, I wouldn't have to count from 0. I can just start at 15 and go. But if you change the scale at all where you're not counting by ones, you have to label it. And if you don't label it, then it's implied that it's ones. Again, I like to do this for one, it helps communicate to you guys what I'm counting by, but also it helps my counting go easier too. So I just like to label my 5s. It takes too much time to label them all. It gets kind of messy if you label them all. So with the green inequality here, so it says the y-intercept is 12, so I'm going to start at 12. It says the slope is -1, so down 1, right 1. So if I'm going down 1, right 1 each time, I should end up at 12 on the other side as well. So I should go from 12 to 12. And then because that's an equals to, that's going to be a solid line, not a dashed line. What's up, Brian? Because it says y is less than or equals to, right? So it's a solid line, not a dashed line. Right here, Friday? Okay. So I think we talked about, like, if that just said y is less than, then that would be a dashed line. This is y is less than or equals to, it's a solid line. On the red one, so y-intercept is 10. On down 1, right 2, so down 1, right 2. So that actually gets us all the way up to 20, so I should go from 10 to 20. Again, that's an equals to line, so that's a solid line there. Next thing we need to worry about is the shading. So that says y is less than -x plus 12. So remember, that means we should be shading below. So if you wanted to, you could do some light shading this way. Again, I wouldn't do that on this type problem if I were you guys. Instead, I would do the arrows. It gets a little bit too messy sometimes if we do that. So the next one also says y is less than. So we should shade below. So we can see where it's double crossing. So we're trying to see, Brian, is that the solution should be in this space where they're both shaded, not out here, not here, and not here. But we're looking for that place where they're both shaded. What I would instead, think for you guys might be a little bit better is instead to do the arrows. So if y is less than -x plus 12, say, okay, that's going this way. Y is less than -1/2 x plus 10, okay, that's going this way. We can still see where the arrows are pointing. Remember, we have our 2 implied inequalities as well, that x is greater than 0, which means we're to the right of the y-axis, and that y is greater than 0, which means we're above the x-axis. So you can see all those arrows are meeting in that quadrilateral space in there. So this should be where the solutions are. At any point in this space should work. And so that's the idea here, Brian, is that any point in here should satisfy all these ideas. Okay. Anything about the shading, graphing stuff before we move on to the next part you want to talk about? Kylie, you doing okay? Yeah, let me do all right. So we've graphed. Now we want to find the coordinates of the vertices. Remember, a vertex is a corner of the shape. So we very specifically go and look at the corners. So right here, right here, right here, right here. Not do a great job graphing. I think this one's supposed to be, it's supposed to meet there. So it should meet at 4, 8. Where that one's supposed to be, my line is a little bit off. This one's at 0, 10. This one's at 0, 0. This one's at 12, 0. So find those four corners to your quadrilateral. So the minimum or the maximum will lie on one of those corners. So again, any point here inside of this space will satisfy, but a minimum or a maximum will always be one of those corners. Okay? And we're trying to maximize our score. So our next job is, once we have those points identified, is we're going to plug them back into the objective function. So now we're going to use our points function that we wrote a while ago. Now we go back and plug in those 4 points. Can we all agree that 0, 0 is not going to give us our highest score? Okay? You can't agree with that?
No.
Yeah.
Okay.
Okay.
I said I was going to know it's not.
Yeah. So we can know that that one's not going to give us the highest score. So what we need to do is go ahead and test these other 3 to see which one of these 3 is going to give us the highest score. Okay? So I'm just going to go ahead and check out the absolute lowest one there and say, nope, not even a chance. So what I'd like to see from you guys is that you write down the points, so 0, 10, 4, 8, and then 12, 0. And you're just going to run them through that function real quick. So 6 times 0 plus 10 times 10. That'd be 0 plus 100, so that'd be 100 points. Good score. Then we have 6 times 4 plus 10 times 8. So 24 plus 80 is 104. Better score. And then 6 times 12 plus 10 times 0, which is just 72. So our job was to find the highest score, which of course would be the 104. So once you do that, you want to go back and say, well, what does this actually mean? What did that 4 and that 8 actually represent? And that goes back to the very beginning of the problem when we defined what x and y were. X was the number of computation problems to do, and y was the number of graphing problems to do. So that's what that's telling us. 4 computation problems and 8 graphing problems would be the best combination, where you can get it done in the amount of time and doing the appropriate number of problems. So just taking that and interpreting it into a short sentence. So that was a lot of stuff that we just did, a lot of little skills that we used to figure that out. Is there any part of that that's confusing you right now? Is there any part of that you want me to emphasize a little bit more as we're doing the next problem? How something happened? Jerry, you doing okay? June, you doing all right? Jordan? Let's flip it over, try it again. I'm going to ask you guys more questions this time. Okay. All right, so Netta makes 2 wood clocks to sell, or 2 types of wood clocks to sell at local stores. Takes them 2 hours to assemble a pine clock, which requires 1 hour of varnish. Takes 2 hours to assemble an oak clock, which requires 4 ounces of varnish. He has 16 ounces of varnish in stock, and he can work for 20 hours. He makes $3 profit on each pine clock and $4 on each oak clock. How many of each should he make to maximize profits? The first thing we want to do is figure out what the variables are. What's x going to stand for? What's y going to stand for? So what do we have control over that we don't know? What do we have control over that we don't know? Okay. Yeah. How many of each type, right? So the number of oak clocks and the number of pine clocks, right? That's what we don't know, right? How many to make. That's something we do have control over. He can change. I'm going to make 4 of these and 2 of these. Like that's something he can control. But he's not sure about yet. Again, my habit is to do the pine clock first because that's the first one there. Okay? But it doesn't matter mathematically which one you do. But if you switch it, your graph will look different than mine. Not that it'll be wrong, just look different. Everything will just be kind of reversed. How many of each to make? That's what we don't know, but we do have control over it. Okay. The next thing we need is a objective function. So what are we trying to do? What's the overall objective of the problem? What do we want to make happen? Galen, what do we want to make happen?
Get the most profit.
Okay, we want to maximize profit. So again, generally I would say if it's a profit problem, I would just call it P. So what do we know about profit, Galen?
$3 on
Okay, so how would we take that $3 and make each pine clock and use that? 3x, okay, 3 times every x. Okay, what else do you know? Okay, so the profit from the pine clocks, the profit from the oak clocks, and you would add those together. That would give you your total profit. That's our objective function. We write it down, we put it off to the side because we use it later, but not for a few steps. Anything on those two pieces you guys got questions about? Jarrett? Okay. Now we need to worry about our constraints. What's limiting Nedham and what he can do? Amount of varnish, so Jordan. So amount of varnish. So what do we know about our varnish? Okay. So if pine requires 1 ounce, how would I write that? 1x or just x, okay? So the amount used on the pine plus the amount used on the oak, 4y. That can be 16, but is that greater than equal to? Is it less than or equal to? Why is it less than or equal to? Okay, so Jordan's saying he has only 16, so he can't go over that. Could he use less than 16? Yeah, he could use less than what he has. He just can't do more. Okay, can he use exactly 16? Yeah, so less than or equal to is fine. Or varnish. There's our varnish constraint. What else is constraining Nedham?
He only has 20 hours.
Only has 20 hours of work, okay. So what else do we know about time?
Take 2 hours.
Okay, so how would I take that 2 hours for a pine clock? What right there, Mason?
2x, 2y.
Okay, so 2x for 2 for each pine, and then you said 2y. That's 2 for each oak. So if we take time and we add it to time, right? And we should get that 20. So what should it be? Greater than equal to, less than or equal to? Why is it less than or equal to? Okay, so you can't work more than 20 hours? Okay, can you work exactly 20 hours? Okay, so yeah, you could work 15 hours if you wanted, work 20 hours if you wanted. You can't work 21. It's not, just doesn't have the time. Okay, so anything about setting up our, is there anything else constraining here? Any other constraints? Any limits? We do also have the implied, again, limits here of the x, it's not going to be negative, y is not going to be negative. Again, it's not a super big deal if you don't put these, but they are implied. You can't make a negative amount of clocks. So, SVA, doing okay? We talked about this first hour with Ned. I was like, we need to restructure his profits because he's going to spend 20 hours. He's not going to make much money.
That's like $8 under.
Yeah. All right, so we need to get x by or y by itself here. How am I doing? And then divide by 4. So y negative 1/4 x plus 4. Get 2y less than or equal to negative 2x plus 20. Divide everything by 2. So negative x plus 10. Again, those axes should go on the bottom and on the left, since we don't have any negative values to worry about. And then we'll have to talk about, what do we count by to use up the space. One thing you don't want to do is you obviously don't want the lines to go off the space because then you couldn't see them. The other thing too is if you just make your scale too small, then your graph gets all like squished down in a corner and it's really hard to read if it's squished all tiny. So you really do want to try to expand it. Like if we only were like, if it was like negative x plus 2, I'd probably want to, I don't want the graph to like go from here to here. I'm not gonna be able to see it. So I might count by something, I'd say, well, maybe this is 1 and then this is 2, and if I do that, I need to make sure that I say to somebody else, hey, there's 2 here and there's 1 there. I'm not counting. So then I can say, well, there's negative x plus 2. Like that's easier to read than something squished down. So you don't want it all squished into a corner. You also don't want it to, if the line goes off the graph like that, it doesn't help you either. So you kind of got to walk that line, like getting it big enough but not too big. So again, that's more of a feel thing. You don't just, there's no way to like do this. Sometimes you just got to feel that out. So what I see here, I have a y-intercept of 10. I have a y-intercept of 4. The thing is, this y-intercept of 4 has a really small slope. I'm going down 1 over 4, down 1 over 4, down over 4. I'm actually going to get out to 16 on my x-intercept with this problem. So, which would be not very obvious from looking at the equation. So I do actually need to count by 1s here to fit 16. So I'm just going to go ahead and count by 1s here on the y as well. So again, I'm just going to mark every fifth. Say again, Brian?
How are we doing? 16.
Yeah. So if I imagine if I start at 4, Brian, and I go down 1 over 4, down 1 over 4, down 1 over 4, down 1 over 4, I'm going to get to 16 by the time I hit that x-axis. So my y-intercept is going to be 4, but my x-intercept is going to be 16. So that can kind of sneak up on you sometimes. So if you have really very small fraction slope, it's not that it's negative, it's that it's a small fraction, it's 1/4. You got to watch out for them. They're very long, very long lines and horizontally. So starting at 4, going from 4 to 16, that green one. Again, that's a solid line because it's equal to pretty much all the problems you guys are going to do will have less thans or equal tos or greater than or equal tos. We don't see often like pure inequalities where it's like you have to have exact, have to have less than 4. Like it's usually not how businesses work. So things like this. Why is it doing that? So usually they will be solid lines. You don't very, very often see just dashed ones when you're doing stuff like this. What is going on? Why is it not? Oh, I see what's going on. I wonder about that all day. They just upgraded this app, or how soon again? They changed this app recently, and I don't like the new version very much at all. It's being weird. All right, you work this time. Dang it. Well, that's really frustrating. Try it for the 5th time, I guess. There it goes. And the other one is 10. So going down 1 over 1 should go from 10 to 10. Oops. Yeah. The deal is, not a big fan of the ruler on this app, period. Now it's even worse. Rather be doing this by hand. And then again, once we have the lines drawn, we want to shade. So y is less than 1/4, so that's going to be down in this space. Y is less than negative x, so that's going to be down here. So you can see that's starting to push us into this space here. Then we have our 2 implied. All right, so it is pushing us to be in this kind of quadrilateral down here in the bottom left. So here's all the possible answers, but we're trying to find the max or the min answers, which again will always be on those vertices. So looking at the coordinates of each of these points here, so that'd be 0, 4, 0, 0, 10, 0, and then what's that, 8, 2? Yeah, we're trying to maximize profit, so there's no way making 0 clocks is going to maximize profit. So I'm going to go ahead and just cancel out the 0, 0 one. We'll check the other ones.
Those ways.
Right on it. Some problems just don't age very well. So plugging those back into your objective function, the p equals, so 3 times 0, plus 4 times 4, so 0 plus 16 is 16. 3 times 8 plus 4 times 2, so 24 plus 8, which is 32. And then 3 times 10 plus 4 times 0, which is 30. So again, it's that middle number that's the same as the max. That is there's nothing ever telling us that middle number has to be the biggest one. That purely has to do with how these numbers relate back to this equation here. And this shape here has nothing to do with these equations. So if we had made, like $10 profit off this clock and then the $3 off this clock, then this point probably would have been the best one. Okay, so again, don't always think it's the middle one of these. It's not by any means. These points here were not related to this equation at all. So it's not until we go back and plug them back in that we actually know which one's best. So it just happens to be that both times it was the middle one. That's just a coincidence. So again, what does that mean? What did 8 stand for? That was the number of pine clocks. 2 stood for the number of oak clocks. So make 8 pine and 2 oak. So just interpret your answer, make sense of it. Okay. You guys do have one minimizing cost question on your homework. There's 3 questions we gave you guys to do. There's one that's a minimizing cost, so it is a little bit, slightly different in what you're being asked to find, but the process is the same. Just, again, writing your function, writing your constraints, that's always the trickiest thing. So if that's what you want to be doing before you come back tomorrow, and make sure that you're clear. Like if you don't feel like graphing yet because you're not sure if these are right, I get that. Okay, so it's going to be really frustrating to find out that you wrote the wrong constraints and then your graph's useless. Okay. So at least be putting time into defining your variables, trying to write your objective function, write your inequalities. And if you can get that done, obviously the rest is just work, but this is where all the thinking is. Can you think your way through these things here? And the rest is just, work that you should be able to do. So guys have 3 problems. At least try to do those, steps 1, 2, and 3. By tomorrow, we'll be talking about this more tomorrow, some more practice. Okay? So give them a shot.